Hello, today we're going to take a look at how to write the equation of rational functions given the graph. Or this can also work with characteristics, which are the same things that we're going to pull from the graph. So, first thing that we want to do is use the correct vocab word. And let's start taking a look at these characteristics. So first we look to see if we have any holes in the graph, and this is our removable discontinuities. Since this does not have any, we just don't need to worry about that. All right. So our vertical asymptotes, these are our essential discontinuities. This is at x equals -2. So if that's our asymptote, our factor for this would be x plus 2. Our vertical asymptotes, that needs to go in the denominator. And we're always going to have some a value or whatever other constant that we're going to multiply this by. We'll figure out what that is later. So our horizontal asymptote, we do not have a horizontal asymptote. This one instead has an oblique asymptote, which is this pink line here. Now, if we're taking a look at this, our oblique asymptote, it has a y-intercept of -2 and a slope of 1. So it's 1x minus 2. All right, so that can help us out later. Our x-intercepts we want to check out. We've got at x equals 1 and x equals -1. So for these, we want to take a look, and those factors will need to go in the numerator because that's where we find our zeros. So our y-intercept is at 0, 1/2. So with this, that'll help us find our a value, because looking here, we have an oblique asymptote, because if we multiplied this numerator out, we'd have x squared minus 1 divided by x plus 2, and we'd have some a somewhere. So we want to double check to see, using our y-intercept, to substitute 0 in for x and see if we end up with -1/2. Now, if we substitute 0 in for x, these terms would be 0, and we'd end up with -1/2. So in that case, a is just going to be 1, so our function is just going to be x squared minus 1 divided by x plus 2. If we did our long division, we'd end up with that oblique asymptote. If we take a look at this one, here we again have, we do have a hole in the graph, and I promise it will be more clear on any assessment. So we have a hole in the graph at 0, 3/2. So if 0 is our x-coordinate for the removable discontinuity, x minus 0, or in this case, just x, needs to go in the numerator and denominator. For our vertical asymptotes, we have one at x equals -2 and at x equals 1. So those factors go in the denominator. So we've got x minus 1 and then x plus 2, because again, we use the opposite sign, that normal relationship between factors and zeros. We do have a horizontal asymptote here, so we have no oblique asymptote. So our horizontal asymptote is at y equals 1, so that means our ratio of our coefficients will have to be 1 later on, and we will have to have the same exponent in the numerator as in the denominator. So we take a look at our x-intercepts. We've got -1, and then we also have -3. So those will go in the numerator. So we have an x plus 1 and an x plus 3. Now, if we multiplied these out, well, because we have no y-intercept, because that's where our removable discontinuity is. So if we multiplied all these out, we'd end up with a 1x cubed divided by a 1x cubed, so a is going to be 1. So this is going to be this function. Now, if we take a look at some that we might have to find an a value for. So we've got, again, let's take a look, see, we don't see any removable discontinuities. So let's take a look for where our vertical asymptotes are. So we have them at x equals -3 and x equals +3. So we have some a value, which we'll deal with later. So we have an x -3 and an x +3 as factors in the denominator, because that's where our vertical asymptotes are. We have a 0 at 2, so we know we have an x -2 in the numerator. Now, this, we have an x-intercept at y equals 0, so we need a greater exponent in the denominator, which currently we do have. But if we take a look at what's going on here, our limit as x approaches 3 from the left and as x approaches 3 from the right are the same value. So what happens there is that term, that x -3, has to be squared. Now, to determine what a is, we want to find what our y-intercept is. We know we have the point 0, 2. So what we do is find f of 0 should be 2 and set that equal to a times, well, 0 times -2. Or, sorry, 0 minus 2 is -2. 0 minus 3 squared is 9. And then 0 plus 3 is 3. All right. So we're just setting up and solving, sorry, that's 0, -2. So we're setting up and solving this equation based on what our y-intercept is. So we can multiply both sides by 27, divide both sides by -2. So a is equal to 27. So the equation that goes with this graph, we have 27 times x -2 divided by x -3 squared times x +3. And taking a look here, we've got still some a that we'll have to figure out later based on this y-intercept of 0, 1. And we're going to use either our y-intercept or our horizontal asymptote with a lot of these to determine what our a value has to be. Let's find our vertical asymptotes. So again, we've got at x equals -3, so x plus 3 goes in the denominator. X minus 4, because x equals 4 is a vertical asymptote. And this, as x is approaching from both the left and the right, it's both equal to -infinity. So x minus 4 has to be squared. Now, our zeros in the numerator, we have x minus 2 because we have a 0 at x equals 2. Now we just need to use that y-intercept to check what our a value has to be. So if we substitute 0 into the function, we should end up with an output of 1. So 1 is equal to a times -2, because 0 minus 2 is -2. 3 times 4 squared is 16. So we'll multiply, well, we can factor out a 2. So we'll multiply both sides by -24. So our a is going to be -24. Let's look at one last one here. So this we know has an oblique asymptote, so we should have a greater exponent in the numerator. So let's first set up our equation. We've got an x minus 1 in the denominator because we have a vertical asymptote at x equals 1. We still need an a value. We have two zeros at 2, so we have x minus 2 in the numerator and x plus 3 in the numerator because -3 is a 0. If we multiplied this out, this would give us an x squared in the numerator, so that means that we have an oblique asymptote. So we want to substitute 0 in for x, so we should have our y-intercept of 2. So we have a times -2 times 3 divided by -1. So this side will be 6a is equal to 2. Divide both sides by 6. So a is 1/3. So we just put a 3 in the denominator here. So we go through, look at where characteristics of the graph are expressed in the equation, and then write those down. Use your horizontal asymptote or your y-intercept to help you find what the a value is. Thanks for watching.